them on a memory stick. So I'm going to try and derive a means to get it through over to you, the first one. And I'm going to try and make it a point that we automate this stuff. Sorry. I'm going to try and make sure we, like you were suggesting, ma'am, that everybody can try and download it from the session almost a couple of minutes after we finish with our session. You can be able to download it. Okay. Is there any questions before we move along? And I'm still audible.
Yes, you are.
Yes. Greatest. Some brainstorming around the previous questions we had. Remember, we spoke about the different kind of, let me just grab a pen a bit here. We spoke about the different kind of message delivery options. We spoke about broadcast. We said broadcast is not very good. Why? It's got noise. All right. So the ones which we like, this we don't like too much. It's got a bit of noise as well. We like unicast and the new baby from IP version 6, which is Anycast. The reason why is because there's not too much noise and it's one-to-one. You see, the rest of the people, they don't really have to hear Benny and Betty speaking, right? Anycast, we spoke about it, that it is about distance. So if we are in Africa and Chinatown is sitting there, rather than our packet, and we've got a server, let's say a web server, they are selling whatever it is, we want to check. Instead of us, let's say the continent, Africa, instead of traversing the whole way to access that point, that server there, the Chinese people, whoever is working on that, they will take the same IP address here and put it and put the same duplicate server here, so that our traffic goes up until here. We don't have to go all the way there. However, that's the idea behind. Noise is a problem. Too much traffic is trouble. Like we move along here. Okay, I thought there was a question. So immediately we add more people to our conversation, we do know that there will be noise. That we can map back to our OSI model layer, which we can really talk some more about. So there is some of the answers which I want you to start thinking more about, but some you need to answer. Okay, so that's, I wanted this one, I didn't answer too much on this one. However, like I said, the more we add traffic, the more noise we have, and it's a problem. So coming back to this one, our boss now needs advice on the two problems which we had here, the problems which we had in terms of admin and traffic. Okay. As I was looking through your WhatsApp last week, I guess, somebody answered and said DHCP is not necessary. So what I did is, as a network administrator, I said his salary will be shared. I will employ 2 more junior salary network administrators, and then I'll share his salary amongst them, because it is necessary. Okay, the reason why it is necessary, it's because of the proximity. We spoke about the nearer, the proximity of the Anycast method of sending talks about proximity. Instead of sending all the way to Japan, we are sending it to a server in South Africa. So talking about the internet, remember, this is, I'm saying a hint. This is the hint. I'm sure we will be looking more into that. Is there any questions before? Do you guys have a bit of a clue of what's going on? Any questions? Any comments? Moving along, going once, twice, thrice. Okay. So trying to map exactly what we are trying to work on. There is Benny sitting here. Let me just try. I'm sorry. Let me try and change the color there so I can try. Remember, from the people I worked with, there is Benny speaking with Betty over here. Okay. In olden days, they could just talk to chorus straight. They actually was at this layer. I'm trying to map it so that you guys can understand. There was what we called a hub. A hub just connected Benny and Betty, and there was too much noise. Remember then, as more people come in, there is noise because why? We are sitting here. The kind of noise we have at this physical layer, it's what we call what? Anybody? There's a domain. What kind of a domain do we have on this side?
I think it's broadcast domain.
No, thank you for trying. It's collision domain, but I really love what you're doing. You're talking to me. That being said, yes, we've got that one. It's collision domain, and this one, it's what you're talking about, my brother. And thanks for saying it. That's the noise we are talking about. We don't like that noise. Remember, we didn't even talk about the hub now because we are talking about switches. And as we can see, I've got SE there. Actually, it's the switch. This switch is at layer 2. Remember, there is the data layer there, OZ. Okay. And now, at the moment, we are concentrating majorly on this guy, the MPLS. Who is this guy? Before we answer that, we need to remember that there is routing. And at layer 3, there is a bonus for us. My brother, like you said, broadcast at layer 2, there is no broadcast at layer 3. We do remember that. So we've got a bonus. And routing, that is the router sitting at layer 3. So now what we want to do, we don't want Benny and Betty to start to go on talk via the hub. The hub is too noisy and there's too many people sitting on there. I remember in olden days, you get a phone call and the whole line will hear you what you're talking about. We were using circuit switching methodology. And you know, the whole line, they could eavesdrop. So that's not good at all. So what happened is then that Benny and Betty went on to connect via the switch. This is history, okay? Because we don't want eavesdropping and we don't want noise. So they decided, okay, let's talk via a switch. I said SE here because the E stands for engine. Those who went through the book, I did go through the book. I gave you the 2 chapters. I'm trying to reminisce and see if you guys can mind map. Once you can mind map this and your mindset, it's about the fuzz. We will talk about the fuzz here just now. Then you are straight to go, good to go, because it's gonna be a long ride and we are going to be fasting. We're going to be speeding or speed, but you guys can stop me at any point in time. Okay, like now, are we still together? Ben and Betty don't want to go that, so now they do switching. In switching, at layer 2, we still have got that problem of noise, which is broadcast. We agreed on that one. So now we want to leverage the routing process because we don't have a broadcast here on layer 3. So what we do is to purchase a bigger machine, okay, with bigger memory, with bigger software and the like. And then we now try to, this machine is a switch, but it's got bigger. So remember, this is switch engine, as I said, and switch process. if you went through. And these guys you already spoke about, I did refer them to you in our class. It was not part of this. I went on back to talk about chapter 2, switching. They talk about the switching engine. Somewhere, I don't know, routing, they say it's RP because the router processes. A router's got memory. It's not that a switch doesn't have memory. What I wanted to come back through to was that there were a couple of major, key things that a switch can do. One of those is hardwire or hard-based switching or whatever, forwarding. That's where are you going now? Oh, sorry. Anyway, that's the engine, meaning we are switching at wire speed. Yeah, wire speed, yes. If you guys remember, that's why I wanted to go back so that we can move forward quickly and catch up. So now we want to take the advantage of wire speed forwarding, okay, and combine it with routing. That's where multi-layer switching comes from. And look, some of them, they go on to say, this is a layer 3 switch. Layer 3, it goes up until the network. However, they did talk about multi-layer switching in chapter 2. I reiterate. They say it goes up until level 4. For those of us who went through the book. So, moving along, the idea is that this switch must be able to do routing capacity. It has to have routing capacity and capabilities, and it has to understand the transport layer. For remembering, the transport layer has got to do with TCP and UDP. TCP has got an acknowledgement, meaning when I send a message to your mailbox, it will acknowledge and say, yes, the message has arrived at the background. Even before you tell there's a mechanism on your pardon me, on your mailbox which will say acknowledge this. That is an additional. TCP acknowledges. UDP, it is best effort. It doesn't care. And it is best used with voice. People get it mistaken. Why don't you want to acknowledge the VoIP? VoIP, yeah, voice over IP. The idea is that when I call you, I don't need the system to come back and say, he answered the phone. And then the next thing I say hello. I mean, the mere fact that you're saying hello, you're acknowledging. So that's why we are using TCP, UDP for voice. Anyway, basically, our switch, we need it to be intelligent. And for it to be intelligent, it has to answer 4 questions, or our network. Basically, let's just to, yeah. It has to answer 4 questions. What are the 4 underlining things, characters of a network that has to be there for our network to be efficient and effective nowadays? Please, can somebody tell me the 4 things which needs to be on our network before we can say it is good for today's work? Like for today's meeting, we are collaborating on MS Teams. What are the basic requirements on the network that needs to be there?
Scalability.
Yes.
And the quality.
I can't hear. Is there? I need an answer, guys.
Scalability, sir.
Thank you. I love that one. There is another one.
Quality of service.
QoS. I just said force here because I wanted you guys to figure it out. It's a Q.
Yes, quality of service, the Q.
Yes. And there's fault tolerance and security.
Exactly. Thank you.
Wonderful. So now what we want our network to be is to be that robust. And for it to be that robust, quality of service is got to do with the need for speed. The need for speed. Now I spoke about proximity. Instead of packet going across the ocean to the Chinatown, they are here. So now proximity has come closer to what we need to look into. In terms of, we don't want, let me try a new, or can I share my board here? Let me see the new slides. Okay. Where was I now? Okay. Okay, let me go back to this one. Let's say we've got this environment. The next thing which happens is if there's any communication across the various lands, what is the next thing which we need? We need a router. A router must be here, sitting. Okay, let's say this is VLAN 1. This is VLAN 2. This is VLAN 3, and so forth. Okay? All these guys, for them to do talk chorus, each and every one of their packets is going to definitely have to go through here. For routing purpose, remember, let's say whenever we want to do IP, we are routing. And the switch, remember, doesn't understand an IP because it's at layer 2. So it means all the communication here, besides it going via the switch here, it has to still go through to this router and back. Sorry. Remember, I even spoke about what we called a lollipop router. They said it's a router on a stick, meaning we have one, yeah, you will remember that one. Anyway, if it's a lollipop stick, it means the traffic goes in and out. So it's twice the mess. So the idea of what we want to do, and talking about proximity, we want to take this intelligence and this work and drop it into this switch so that everybody can resolve things from there. Is there any question? Can you understand really? I mean, the first thing, it's traffic, all the traffic has to be routed. So we want the router to be inside the switch. We take the intelligence of the router and put it in the switch. So the traffic will be coming here and the router will be just here, the intelligence thereof, and it will resolve that thing. For example, now the time, we're talking, finishing up that's for fault tolerance, remember. And STP and them was dealt with by Dr. Topside. It's not part of this. And chapter 2 is not part of this. I'm saying them so that you can clear up the mindset, what it is that we're doing. So the next thing we're going to be talking about DHCP. Okay. DHCP, because it's an IP service. For those of us who remember, DHCP is a dynamic host allocation thing. So it will have to be done by the router. It is usually sit here at the router. So now what we are saying is we are taking the intelligence thereof and we are dropping him here. Why? Even though the traffic won't be much too much and the like, it won't be, DHCP works with broadcasts. That's what we are going to talk about. We even contemplated and spoke about it the last time. There is 4 different types of DHCP messages. And those broadcasts and the messages, they go via here. still there will be noise. And remember, no noise. Network administrators don't want noise. Or people on the network, we don't want noise. I mean, even the users, they don't want noise. And they will be making noise to the network administrator to fix it. Just fix it, they will say. Another example of cumbersomeness, and it comes back to admin. I was talking about traffic. Wonderful. It's good that we landed here. Good. So now I'm talking about admin and talking about the DHCP once more. The guy who said yesterday, the other time that no, it is not necessary. How are we going to resolve this? Everybody wants to be on the network, like we said. The model, all people seem to need data protection now. We've got the network already. We don't need processing. We've got processing. We need protection. That's what he said. I've learned, and thank you, my brother. So now talking about admin and DHCP, look what I did. Admin, and I say admin, network admin. You as the network engineer or administrator have to have things sorted. That is why the boss wants suggestions here. He doesn't want you to troubleshoot and stay at, it's no more technical. He wants to if he wants advice from you, he wants to promote you. Now you are demoted. Sorry. Hopefully you are not demoralized. But what I'm trying to say now is I even asked a question the last time. What happens when you, on your mobile phone, what happens when you put it on? Hold that thought. So here, what we are saying with DHCP, we are saying that if Tom didn't do his homework, and now the time he says he wants to wake up early in the morning and go to the office, he switches off on his PC the first time or whatever. Now he wants an IP address. He has to phone the administrator, the network administrator. Hello, administrator, please give me a network address. Okay, then we will do manual mapping. We will see and talk about these things in the configurations. And that's when you will see that this course is pretty much practical. In which case, there was a suggestion, my wonderful lady, she suggested that we try and become more practical and work on packet tracer. We didn't have much to discuss and agree on. We can agree on that one today. Are we clear thus far? Is there any question? Is there any comment? Talking about DHCP, so we said now we can take this thing, this DHCP service, which if you remember well, when you were doing Networking 101, we explained that there is a DHCP server, and that DHCP server is configured sometimes on an ordinary server or on a router. Today, we are saying that DHCP server can be now configured on a layer 4 router. And some of the services which were done on that server, be it a router this time, they can be done on this. DHCP goes hand in love with what we say DHCP relay agent, also a relay agent. So those who went through the book will know what relaying is. It's like that which, I don't know, Caster Semenya, does she run relay? But the idea is to, you run and give somebody the whatever, the token, so that they can run after for you on your behalf. And what that means is we really don't like broadcasts, and we will see how this guy deals with, because he takes the broadcast packet or message, And then on behalf of the agent or the client who needs the IP address, he passes it over as a unicast. What did we just say now about unicast? We love unicast because there's no noise. Is there any question before we move along? So in addition to all this, oh yeah, remember Ben and Betty, they were just switching their packets now. So now they see the advantage, now they want to route their packets. Why would they want to route their packets? Because Ben and Betty now they are not working in the same VLAN anymore. Betty is running in VLAN 1 and Ben is running in VLAN 88. Okay. For them to talk, they need the routing because VLANs are just ordinary virtual LANs. A LAN is a segment. Okay. So that being said, everything we're doing is to take advantage of the power of the switch. We want to switch our packets. We want to use a wired, hardwired, wired-based something, switching so that we can switch our packets. Remember now, at this point in time, our packet is intelligent. It knows the IP address because it is router aware. It is at layer 3. It knows some of the ports, even in it knows some intelligence in layer 4. For instance, it knows that if I want to go to www, I will go using port 80. Why? Because our packet is intelligent. It contains more information across. Remember encapsulation. Encapsulation is adding more information on a piece of information. Yeah, how do I do that? That's encapsulation. And decapsulation is the opposite thereof. So we want to be switching intelligent frames. Instead of us now having to route and then, remember now we spoke about security. Already firewalling is there. So if we don't want to go via port 80, which is HTTP, we will use HTTPS for security. I don't remember what the protocol is there. That's for you to remember. I am another protocol, another port which you guys need to know. We are going to deal with. It's for SNMP. It's 161. It's for SNMP, Simple Management Protocol. Okay. Yeah. All right, guys. Are we still on the same page?
Hi, sir, can I ask?
Yes, ma'am.
In terms of DHCP relay, can you explain for using on the different VLANs, like how you assign? I know you can assign it on a switch port on an interface, but now if you have many VLANs, instead of having each switch port given DHCP server, like acting as a DHCP server for each VLAN, how would you do it in terms of DHCP relay?
That's what they say. We just spoke about the relaying. Ne? The relaying, it's like, remember the idea is that we don't want broadcast to go from this PC all the way into the switch and all the way across and back. So instead, we want this switch. If it cannot be the DHCP server for a particular VLAN, then it must know the direct DHCP. let's say it must be connected to a direct DHCP server here, okay, which has got an IP address, remember. So this guy will say, okay, DHCP helper, it says IP DHCP helper. This is the thing, it will point the IP address in that direction. What it means, it's this guy will come with a broadcast and say, hey, I want an IP address, please. But then this switch will see, oh, I cannot resolve it. It's not within my capacity to resolve it. However, I know somebody who can help him. So meaning I will put a list of helpers onto this switch, okay? I will say there's a helper IP, this guy. There's another helper IP, this, a list of helpers for whom I'm not able. Remember, the more, the heavier duties I have on me, the more tired. I will even not switch packets anymore. I'll concentrate on DHCP. So instead of wanting to know everything, I just need to know how to get through to them. So I'll know that, okay, there is another DHCP server for here. Okay, let's say I know only for VLAN 1 as the switch. I don't know for VLAN 2. I don't know for VLAN 3. So for VLAN 2, there is the server. There is the DHCP server. On this switch, okay, I know I'm connected. So I'm going to say, I know IP helper. I know if you want the IP address for this VLAN, you can find it here. So meaning the packet will come as a broadcast here. But then when it gets to me, I encapsulate it. I know exactly where to pass it. It will be a unicast. So the noise is now less. Am I clearing? So the same for VLAN 3. When he comes to the switch, remember now the switch is a server for this VLAN. However, he's a relay for this one. He knows that DHCP for VLAN 3, I will find it on this IP here. I know. And that is configured by IP helper thing. Are we together? Hello?
Yes.
Do you understand me, Mama? Very good question. When we get through to it, we will be done with it. You saw we went through it. So you guys will be looking into the configurations, and you need to interpret the configurations. For example, a question will come and say, I will just say show this and say there is the display. From the exhibit, what does it mean? Okay, you must tell me, oh, this server, this switch it's a DHCP server for a particular VLAN, and it is at the same time it is a relay for a certain particular VLAN, and just because you could read the locuzan, the question is not going to say please list the options of, or yeah. Are we clear? Meaning we are going to try and do application. If you can already see the questions which I'm asking and having you guys to think about. We are thinking about fuse. We are thinking about this. Today's networks, the applications, they must be fast. They must be secured. They must be scalable. And the rest, and. Did I answer the question clearly? Any other question? Are we good?
Yes, the question was answered very clearly. Thank you.
Wonders. And then they talk about these things. We went through what Wait. We are there. Okay. Are we? No. Oh, okay. So the objectives is IP version 4 and IP version 6. Remember, there's the difference. So yeah, we spoke about the relay. The idea is the relay will take a broadcast packet from the client, and relay it as a unicast to the DHCP server. Okay. So moving along, configuring IP when a switch is configured with the becomes the router or the default gateway that connects host that will use on for that local VLAN. Okay. How do this host know the interface, the layer 3 interface as their default, and how do they know what IP address to use? Remember, the PC just came up. It's a brand new one, like the new ones we bought from Zingy there. So how would it know? It doesn't have an IP address. So yeah, this is what should happen. Yeah, there's two popular methods to do it. The manual one is the one which is not very good for fast things. Remember, we joined the industry. I personally joined the industry for automation. Not that I'm lazy, but if it can be done in speedily and accurately, if not, why not? So that's why manual is not good. However, it is good sometimes. We'll explain. Yeah, DHCP is this one. However, then let's go back. Why would you want it to do things manually if I just said automation is good? Sometimes you've got a server. That server is a mail server or a web server. You don't want a web server to change its IP address every now and then, because things will go AY, People will be looking out for the mail server, and the mail server IP address will be taken by another end user or by my laptop or the IP address thereof. So that's when manual is good. When you've got specific servers or hosts, whatever, that needs to have a peculiar IP address, which must not change. Changing it is not good. It's not good at all. Okay. Other than that, we need to leverage the power of DHCP. And okay. Other than that, we need to look into DHCP. So what happens on your smartphone when you turn it on? Yeah. I have already asked that question. For example, this actually, I think it goes in the lab. A host connects to the network that does not yet have an IP address, as we said. It needs it to require it via DHCPS. How can it send a packet to a DHCP server without it having a valid IP address? Remember, we are talking about IP version 4. We've got a different story for IP version 6. Those who went through the book, they really know. Yeah, so the answer is that they will be negotiating. And these are the messages which are going to be negotiated, used to negotiate. The client will do a DHCP discovery message, which is a broadcast, and we'll go and look into the book now. And then the server will offer, so it will be the client shouting, "Hi guys, I need an IP address." So there will be a couple of servers. The servers will respond. Then the client will say, "Okay, I want that one." And then the server will say, "All right, Tatam for which." And then Talk Chorus come into the picture. Are we together? Let's look into what did they say? I didn't write what page. Guys, what page is that one? What page is the DHCP story?
292.
292. Thank you, man. Really appreciate. Really appreciate this. Greatest. There we go. There is the story I was talking about. Okay. So now take note. I said this is noise. We don't want a broadcast, so it's noise. We don't really like it. This one replies with an offer and contains that one where was pasted there. However, already we discovered that we don't readily appreciate the noise, and that's when we have to understand. Guys, I don't have to go through all this. I've just said what they say. If you'd like, do you guys like to go through this one by one? Hello?
No, we actually check the chapter,
No.
so we know what they say.
Wonderful. Yeah. That is why.
Can I just ask something?
Yes,
Sorry,
ma'am.
Syed. Can I ask something regarding DHCP as a whole?
Okay.
I'm just going to give a scenario. So let's say you've set up your DHCP on a server, right?
Okay.
And I know DHCP has a database where it will be releasing, let's say if it's /24, it will give those IPs. Then maybe someone decides to go put in an IP manually on the device, right?
Yes.
Granted that at that time that IP is available, they will get a connection. There won't be any IP conflict. But along the way, depending also, I don't know if that depends on the lease on that VLAN, maybe that you said at least it's 8 hours or 5 days. Then eventually, along the way, the device or on DHCP, it will show inactive. Yet the IP is not used by any other device. So what I wanted to ask to confirm, I'm assuming that because it was not issued by DHCP, when it goes maybe and check their database or whatever, or when it goes and refresh or update the database when the lease ends, because it didn't assign it, it doesn't consider it. Hence, it goes inactive, where now it will have network problems and everything. Yes, it will work, but there will be that packet loss and everything. So I just wanted to ask, am I correct by looking at it that way, or there's another explanation?
Can I open it up to the class? I'd like a suggestion from the class. I really appreciate
Yes, it's fine.
the way you put it. Guys, can you help our colleague here? Somebody who understands it better.
The question was a bit vague. Can you summarize it, ma'am?
Okay, what I'm saying is we have a DHCP server, right? That's configured for data, for instance. So what we have is the VLAN. Well, DHCP assigns the div list addresses automatically, right? Yes, but someone, let's say a desktop engineer from your side decides, okay, I'm just going to give this machine an IP address, and then they put it manually. So they do the manual one. So they do the manual one on the machine under the NIC there. say they give it maybe .12 on that network. It works, but now on DHCP, yes, it will even lease maybe it's Android something. But after maybe or the device on that DHCP, it becomes inactive. It shows inactive. So at times it loses networks. That means that, well, my theory was because DHCP is meant to assign the IP automatically. It's the automation, but now it's done manually by a person. It doesn't like that. Yes, it might work and go through the process that it needs to, which like now I just learned the steps after we discussed. Now there's a discovery one where it will release, and then after it acknowledges those 4 steps. So now I'm saying, could it be now the reason that the other one becomes inactive because it's not part of this process? It was sort of by Robile, they did it manually. They put it manually, and it's a DHCP.
Okay, let me try to see if I understand how you're putting the question. Okay.
Sorry, can I come in first?
Yes.
I think I understand her, and you are, and she's right the way she understands it. In which manner? Because remember when the DHCP releases the addresses to the machine or within the network, it will depend on the time that how the administrator said it. Maybe it gives it 5 days, a week, or an hour. Let's say give it 48 hours. Today I'll go on Tabo's machine. I put 10254.12. Then when the lease time expires 12 o'clock midnight, that IP address is not going to work on Tabo's machine, because the new lease will have happened after 48 hours. Then all addresses will be sitting on the DHCP on the DSPC server. I'm not sure if I cleared it for you, but I think the way you understand it, you are right.
Okay, thank you, Anthony. Yes, I just wanted to confirm that, because I've been asking myself, but after we've just went through those options, it also makes sense. Okay. Because it went and refreshed after the lease.
Yes, and remember, it expires, but then the DHCP remembers, and the table. It's almost like it wouldn't just take the one which was used and reuse it immediately. It at least tries to take from the ones which are not used for quite some time. However, the way my brother put it, there is what if has this backup? Can you hear me? Can you hear the echo?
Yeah, it's a bit also delayed.
Okay, but am I audible? No?
Yes.
Right. So remember, to me, the DHCP server, the client requests, the DHCP says, okay, this is what I have. And somewhere it has to confirm. The client comes and say, okay, I like this one. Maybe he liked the wrong one, but then in the DHCP must be aware.
Okay.
Okay. And then only then the DHCP acknowledges and confirms. Then it will mark it that, okay, this one belongs to the MAC address. Another technicality is that, look, the NA who's running here must be talking to this NA. Because how I understood is mistakenly some NA, the other one, the junior ones, which we hired for my friend who doesn't like DHCP. Yeah, there must be consensus And then remember, for such kind which are reserved, they will be excluded. There is a statement inside DHCP that excludes. It's for you to find out and for me to know. Are we clear?
Yeah, there's a hand from Portia. She needs to
Yeah, I
talk.
actually wanted to understand Dewelling's question because I think I didn't understand one part. Because I thought if you put it manually, meaning you put it static next, and
Yes.
the ones you put that like normally what I know is that on the DHCP you will put reservations where certain IP range will not be part of the list. And those are the same IP addresses that you can use and
Yes.
and manually.
No. Okay, maybe let me explain it this way. In that sense, yes, if that one is not part of the list, if maybe you reduced your scope that to release maybe 12 IPs or maybe to up to 25, then you giving it maybe 26 or something, it won't happen. But if it's within the scope where DHCP needs to release it, it will. Even if you've added it, you add the IP on the machine, right? And then you go on DHCP and add it manually if it hasn't picked it up. You're saying that maybe .10 and then you give it Portia's machine. You reserve it. Even if you've reserved it, because remember when you reserve a machine, you know that it won't lease it to another. But now, in this case, because we used a DHCP lease, that DHCP didn't give it to us. We reserved the one that DHCP didn't give it to us. So at that time, DHCP didn't even pick up that machine or didn't lease that machine, didn't give it that IP address. So you just decided because, okay, I've just plugged it in, while maybe it was that process where it was still to discover the network, right? To send a discovery to DHCP to say, hey, I'm here, I need an IP address. When you've already assigned an IP address because you know the range, right? Because you normally say ping this IP address and then it's not taken by anyone. And then you say, okay, I'm giving it to Portia's machine. So when you do that, DHCP hasn't discovered the machine yet. So you've given it. So you go manually on DHCP. Also, you reserve it where you right click and say reserve. You add the IP address and the MAC address. But after the lease day, it will say, maybe after that 8 hours, it will say inactive. That means that it has expired because, yes, you manually forced it instead of the automation where maybe it goes look at the list and say, okay, this machine, this IP is given to this one. So now we're releasing it and we're going to give another IP. But now it sees it as, okay, I don't have this log here. I guess that's why it puts it inactive, but it's on and off. It can work, it might not work at times. So maybe also this, I see it as a confusion to the process of DHCP itself. Hence, it puts it on inactive. At times it will work, at times it doesn't work because it doesn't find where it is. I don't know, it doesn't have that capacity to actually, because it's designed to say, I'm giving you automatically. I'm issuing the IPs automatically to discover the machines and list the IPs. Now, when I get something that was done on a site and inserted on me, like giving me the machine that I didn't discover and the IP, then it confuses it. That's why it puts it on inactive. Does it make sense?
Yeah.
Yes.
Okay. Yeah. Okay.
Thanks.
All right. Thanks, guys.
Yes, thanks for coming up with that's a very intelligent question, and it explains the reason and the idea behind exclusion and consistency of work. The various network administrators must be aware of the network, because something like that, if people do a mistake like that, it can really shake the network big times. So yeah, care is everybody's issue in this particular instant. Yeah, all right. So yeah, this could be part of what you're saying, then this negotiation, it's very important for you to understand and the leasing thereof. So, yeah. Okay, moving along. They said now, look, because DHCP is dynamic, the IP addresses are offered listed before the offered list time. Sorry. Before the offered list time expires, the client must try to renew its address. Otherwise, that address may be offered up to a different client. So notice that DHCP is designed to work within a broadcast. So that's the issue. That's why I'm talking about the noise here. Most of the messages in DHCP are sent broadcast on the basis of the DHCP server will be need to be located in the same broadcast domain. So now we're talking about proximity. You know, proximity is good. Going back to, we don't really need to hop, meaning to jump many intermediary devices, okay, before we get a service. For example, that of DHCP. So we talk about proximity. The closer it is, the better for the network. Yeah, that's what we are saying there. So now that, okay. This design would require one of each, all right. So this is when we speak about and we introduce the relay. This design which we have, and I think we already went through a question like this. The design we have, it's for one server, DHCP server on each broadcast domain or LAN, whatever, on the network. So something which is not really practical at all, not at all. It's pretty expensive. It's just not practical. So you can get around this requirement by doing a relay on so that the relay can do the negotiation. Remember the negotiation? This part. 1, 2, 3, and 4. Discovery of because there is broadcast, we would like somebody to stand in on our proxy so that he can relay and say, okay, they're talking broadcast to me. I don't want the broadcast to go any further. So I will unicast it and send it on along the way. Okay, we discussed that one already. So yeah, unicast is good because there's no noise. Next, we go to discuss the configuration of this one. First, to configure it, remember this is in IPv4. So if you want to come on, what did I do? Okay. To do the configuration, first they say you need a layer 3 address. I mean, this cannot be more in almost every time. Yeah. Remember, DHCP it's service. It deals with IP addresses, and IP addresses are at layer 3. So by default, the switch must have a layer 3 thing, IP address. One of the things which means will happen to what is the command to make sure that a layer 2 interface becomes layer 3 workable or away. Guys, question for you. Hey, they're selling it now. What switch command do you use at IF config level to make sure that the port is layer 3? Okay, yeah. Almost like, yeah.
No switch.
Yeah, say it, it's fine. That's it. So for you to do it, it must be no switch port. Maybe I can put it here now. So the commands here, can I cut? This is no switch port. SP, switch port. Then in this one is switch port. Remember switch port you used it in chapter 2 or beginning of the thing to say switch port, this thing, it's block it or do things, but those commands were in at layer 2. Our switch was not intelligent yet. So that's why we're talking about no switch port for it to be in. So yeah, for you to do IP related activities, they just snap it up. Then what you do is you configure this server that runs on the switch itself. So you configure a pool of addresses. This pool is the ones which you want to give to the people. And if you have some which you don't want to give to the people and you want to reserve them for the servers, that's what you do. You do the exclude. I think they say, yeah, the exclude thing. Command, switch port, the exclude command, and yeah. The result is that this switch now, when it is it's going to start to intercept the broadcast packet line within the VLAN. And that's what we need. We don't want them to go across. So there is the exclude address we were talking about to say these ones are going to be for servers and the like. There is the way you do it. You name the pool there. Okay, and the list time, the list, sorry. This is to say the list, how long you want to use it, for it to be rented out. Remember, we are renting out, we are leasing out. So how long? If someone say, okay, I already went through that one. Are we clear with that one? Configuring it manually?
Yes.
Great. So we already touched up on this. I'm not sure what's happening with this. Can we mute our mic? Maybe that's the problem.
I just have a question,
Oh, yeah.
sir. Sorry.
Thanks. Okay, sorry.
Yeah. Well, the previous slide, right? It's us configuring DHCP on the switch.
This one,
right?
yes. Yeah.
So now, in a case scenario of having a DHCP on the server, my understanding is it would not work even if I set the scopes and everything on the server itself, that VLAN. It will not work if it's not added on the switch. It gets the instructions from the switch in order to, it's more of switch doing the route or telling it what to do. Then it can apply those rules that are there, that you have 8 days lease, and then you have this much, how big is your scope and all that. Am I correct by saying that? You may have a DHCP configured on the server, but you still need something about that VLAN on the switch configured.
Let me try to understand if I to picture my understanding. Are you talking about this? There's the DHCP server, there is the switch.
Yes.
So you are saying, and there is my laptop there, yes?
So what I'm saying is configuring a DHCP server, right?
Yes.
That DHCP server still needs to communicate with the router or switch in order for it to function well or do the DHCP job. So what I'm saying is there must be...
Please, madam. Let's just hold that thought. Yeah. Okay. And remember, we're talking about proximity. What we want to do is not to say to do what you're saying, unless if maybe I'm getting confused. We want the function of the DHCP not to be remote from the switch. So we want this, and we want the function of a router not to be remote from the switch. We want it to be on the switch because of proximity. The nearer, the closer, the better. This is from here. So remember we said DHCP usually runs on a router or an external separate server. Now we don't really like, let me go back to the, this one. This guy wakes up, this PC wakes up, yeah? And now it doesn't have an IP address. It wants to talk. So because the switch at the SE, the normal layer 2 switch, because it doesn't understand IP addresses, né? It will broadcast. This will broadcast and say, I need to talk to somebody. Where's Betty? Betty, my Betty, naman. And then the switch will say, I don't understand you. It will pass the broadcast through to the router. There's the router. And this router, in this case, is the DHCP server. It's got a DHCP server configured on it. We went on the switch. Instead of this, on the router, we will say here. Forget about the switch, router, everything. We configure this on the DHCP, on this router here. Okay. So this is not good. I'm complaining that we don't want noise. So why this noise going here we don't like? That is why we take the function of the router and we put it in the switch so that we can leverage the benefits of switching at engine speed, wired speed, at the same time take advantage of the routing process or routing functionality. So what does that mean? Part of the routing functionality is the DHCP. So we are actually taking the DHCP and saying, oh, we want our DHCP to be here. DHCP, yeah. What does then that mean? It means that this broadcast is not going to be there. Only this broadcast will go through. It means we are saving. It's good. Are we there? You can ask the question now, maybe, unless if I don't really get to understand you.
Maybe I'm not explaining it the way you, well, I'm not explaining it better for you to understand because I just got confused there. So basically I was under, just when you're explaining, I was under impression that if you're saying that is a switch, and then if it doesn't understand it, it sends it to the to the DHCP server.
Yes, that's what I said.
Yes, but now I say I see you also said you add a root when you add a router instead of we reducing the noise, and then the router will send it straight to the DHCP, right?
Okay, let me start again. Is there anybody who can try and help me out? I'm going to reiterate. This okay, let me see how else to put it. Let me try maybe this one. I don't know. Let me try to go back one step. Remember, we had I think 2 or 3 what do you call them? Diagrams. One of the people was asking, why do we like the one diagram instead of the other? there was, where do I get that document? Let me see quickly if we can get through to it. Where are you? Through to it. Yeah, last week. There. No, not this one. I said we like this one. I wonder where it is. No. It's not, it was not, it's in the book, I think. It's not on this one. Anyway, if we connect devices, the more close, the closeness. Okay, let's do a new page. Let's try on a brand new page. Yeah. Okay. We've got a device, a PC sitting here. We've got an old switch. That's why I say SE. An old switch, which is at layer 2. If these things are like this, connected, they can never talk IP. They will just talk MAC addresses. If they want to talk IP, we need to put a router to be there. Okay. So now, if we want to talk IP, we put a router. Remember, this router can be a DHCP server at the same time. So now we've got an issue. Benny wants to talk to Betty, and you know, we are using the old way of doing things, switch 1, engine switching there. Benny used by layer 2. It's not good. Why? Because for Benny and Betty to talk, Betty is sitting here. Okay. For Benny to talk to Betty, IP, with IP addresses. The packet, a broadcast has to go from here. It has to cross the switch. It broadcast again, it goes to the router. The router comes back with the broadcast and say, oh, there it is. And then only then, maybe later. Even communication, then it will have to go there and back there. This is a mess. It's not good. What we want to do is to take the intelligence of a router and a DHCP server and put it closer, proximity, next to us. We don't want to jump and hop towards. Remember intermediary devices? A switch is an intermediary device, so we don't want to hop. Why should, if this switch can sort out our problems, why should we jump it? That's what we are saying. I'm not sure if you were in the first, when I explained this. We want.
So I was, and
yes.
Yes, I was in class, but also this, my questions also is for me to confirm if I've understood the other parts, because of maybe what you're saying now, I'm getting confused. Hence all these questions, and to confirm if I'm still in the right path. So maybe if I would rephrase the question.
Okay.
Yeah. So what I'm saying is, let's say we are using a server as DHCP, right? I would believe a structure will be like a machine, and then we'll have a router, then a DHCP server. Is that going to be better?
You're there?
Yes. Can you hear me?
Yeah.
Yes, so I'm saying, will that one be a better sort of a diagram for me if I want to set it up like that? So what I wanted to say also is, it doesn't, if we have a server as a DHCP server, the machines or the request will be routed by a router to a DHCP server. That means we still need not necessarily a switch. We still need.
But the router itself is the DHCP server, isn't it?
Yes, but I'm saying I'm just giving a scenario that other environments have. So I want to understand.
Draw your scenario. There's a switch. Do you want it to be a layer 2 or 3 switch? You want it to be a multi-layer switch or an ordinary switch?
You can even make it a multi-layer switch.
Okay.
Can I come in again?
Yes.
I think she needs to understand what is the relationship between the DHCP that's been configured on a server and the DHCP that's been configured on a route.
Is that the question, Mama?
Is that the question? I think.
Yes, Anthony. Yes. Thank you. Yes.
Yeah.
So you want to know the difference between the DHCP sitting on the switch, or on the
server and then the switch.
On the separate server and on the switch.
Yes.
Okay. Traditionally, we will be using a layer 2 switch. A layer 2 switch does not know anything about DHCP. It does not know anything about IP addresses. Okay, so we will have a DHCP server sitting there, which will help with the situation. However, even before this DHCP server, we need a router if we talk about IP by default. So usually the DHCP service, it will be running inside a router. The router itself will be the DHCP server. Do we understand each other thus far?
Yes.
So what you are envisaging is old style. We don't want that. We use that if we are using a layer 2, and I'm going to write it as SE, a layer 2 switch.
Can I interject?
Yes.
I think you are not answering her question. The question she initially posed was that let's assume we have a layer 3 switch, okay? And then from from your diagram, we have a DHCP server. Now we upgrade the switch that we have into a smart switch with all the routing capabilities. But bearing in mind that you still have a server, a DHCP server sitting somewhere. So after initialing ports, her question was, if you do not, again, initial all the ports or all the IP addresses on this DHCP server, there will not be any communication. So similarly means that the relationship, if you have both these in your network, there may be communication breakdown if the IP addresses are not, or the DHCP server and the smart multi-layer switch layer 3 are not, configured or to correspond with the IP addresses in range. That's what I've understood. Am I diligent? Am I answering you?
Yeah, I think yeah, but I do understand that's what I wanted to understand, that the relation. So that means the DHCP depends on whatever that's configured on the layer 3 switch to actually be able to function exactly how it is. If maybe whatever the root or a command or a configuration is not in the switch, the DHCP server will not be able to do its work.
Exactly. That's how
Can I ask you guys the question? Why will you want to have a layer 3 switch sitting here and a DHCP server?
It's a structure in place. So what I wanted to know is,
why you want to have such an environment? Because you
But
can,
what I'm saying is, I want to know the right way. Hence, I'm asking you as a professional, because I'm not in networks department. However, I understand the network concept. So I'm actually now taking this scenario with the lecture that we're having to find a way, so that even if it's me next time who has to be a network engineer, I can be able to apply the correct principles in terms of what I've learned from this course. So I'm now asking, so I was just asking to get more understanding that, okay, that means that one, it's not the right way. And I've also...
Just hold on, sis. I will tell you when can you have this environment. I'll answer myself now, okay? If you have Peter sitting here and David, and this guy is in one lane, VLAN 1, and this guy is in VLAN 2. Yeah. The switch can run as a server. It will be a DHCP server for VLAN 1, which is this one. It will be a DHCP server. However, for VLAN 2, the switch will do two functions. It will be a relay, meaning, okay, you are not using my, let's say this one, it's using the 10 range, 10.0.1.0, okay, and this one is using 10.0.2.2 range, okay. These two lengths are not in the same, so the DHCP for this one can be running here to say, okay, I've got a pool of DHCP servers for 10.2 for you, okay, for 10.2. But this one, the one on the left, VLAN 1, this switch is running straight as a DHCP server. This is the time when you can have that scenario. So this switch is going to be running as a server, DHCP server, and it will be running as a DHCP relay for the network, which is sitting here. Somebody asked nicely a question. If you've got multiple VLANs, then what? And we already went through that. This is what you do. If you've got 3 VLANs like that, then you can have a router sitting there or a DHCP server separate and tell this guy that there is your, then that's when you are going to say IP helper inside your configuration, and you know that your IP helper, you point it to say it's this guy, this router or this DHCP server, it's your IP helper, meaning there will be no broadcast going here. There will be only unicast. Alternatively, so do we understand this pitch? Thus far, do you understand?
Yes.
Okay. Alternatively, you don't really need the DHCP server to be there. If let's say you've got one VLAN, let's say. Okay. And let's try and keep it simple. For now, we've got only one VLAN. Okay. We don't really, how do I put it? We don't need this scenario. We need the server, the router, to be close. It must be, we just need to remember a router is software, it's an app. So we take the routing app and we throw it inside the switch. And the DHC server, it's the service, it's just an app. We take that DHCP app, we throw it in the switch. What does it mean? It means our packets are going to, proximity is good. It means our packets, it's from this node straight to the switch. Problem sorted, whatever. We don't have to go all the way through to do routing or to do DHCP. That's all what these 2 chapters are saying. Am I clear?
Yes, thank you.
Okay, before we move along, is there any other question?
Sir, I just want to ask one question.
Yes.
With the IP helper command, therefore it means it just points other DHCP functions or what you call VLANs to the server, then you configure everything on the server.
There is the relay. Can we go through it together so that maybe you can get the answer? This IP address here, it's for this guy on the, remember I said, yeah, back here, is for this server here. This switch will say IP helper, IP address there. Meaning if anybody has got a broadcast that I don't understand, then I cannot sort out because I'm a DHCP server myself as a switch. If I don't understand, then I'll throw the packet over here. What is the advantage? I'll throw it as a unicast. It's not a broadcast. I'll not make noise. When I try to resolve that. So shall we go through it so that we can try and get. In a large network, you may encounter a DHCP that is centrally located, meaning it is not on the switch. Remember, we're trying to put the DHCP server on a switch. We want to, that's what we are learning. We just did, that's what we just did. We configured, did we go through this? When we do this on a switch, this means this switch is going to be acting as a DHCP server. It will be dishing out IP addresses to clients so that clients can do whatever they do best. That's what we're saying. Okay, so now we are saying sometimes if the network is too large, we will need a separate server. Sometimes this can be a router. So okay, that is centrally located rather than distributed on each switch. In that case, you can configure the multi-layer switch to relay DHCP messages between client and the server, even if they are not located on the same VLAN. They are on different VLANs. First, you configure the layer 3. This is always the case. You cannot do anything on the machine without configuring the layer 3. And then next you use this address helper interface, like the example they gave. Interface VLAN, that's my IP address, and then that's the helper's IP address. That's what we was talking about. We went. So as a DHCP relay, the switch will intercept the broadcast messages. Broadcast is noise from the client, and it will forward them as unicast messages. The switch keeps track of the subnet where the client message arrives so that it can relay the DHCP response back appropriately. You can configure more than one address for a helper by repeating the statement. So they say you come here and do another one. You say another helper, let's say dot 17, and then another helper dot whatever. That's what they are saying there. That you can repeat by repeating the IP address helper command. Okay. Are we okay now? That's fine. Can we move over to, are we satisfied with? And configuring DHCP to support IP version 6, yeah, it's one thing. This version offers some very efficient and convenient mechanism for these devices to use when they join the network. Remember, we want an IP address because we want to join the network. Actually, we want to go to the internet. By discovering a local IP version IPv6 router a device can learn. So the device first, it has to discover the local IPv6 router. So a device can learn which prefix so that it can understand the prefix. And then it will use this prefix to generate its address. Okay. So they say a device can learn about which a device then amends this its own interface or the MAC address, which includes the MAC address. So it actually generates its own. Even though the link local address might seem unique, the device must always make sure to do the ping, do a DAT, a duplicate address resolution process to itself to see if any other device might be using this same address. So immediately it wants to check, duplicates. It doesn't want to mess up the network, because duplicates means more than the network, the bandwidth is being wasted. We don't want waste, we don't want noise. So if the address proves to be unique, then the device can begin to discover any local router that are connected to the local network segment. The link local address provides a means to come online and learn about layer 3 surroundings with very little intervention. So you see, that's why they love IPv6. It's got many addresses, at the same time, many advantages. There's one advantage which they said. A client coming up, it can automatically generate its own IP address instead. We went through that. Ultimate goal of any device joining the network is to find the global unique address. This is like your public, is it public? Yeah. This is like your public IP addresses for IPv4. It's like the public, IPv4. Remember, private ones, they don't go out. And that's what the link local address are associated with. To communicate. In the IPv4 world, this can be done through a static IP configured or dynamic. Okay. IPv6 is somewhat different. A device can be configured with a static version IP, or it can obtain an address dynamically, but normally through this one, not normally through DHCP. I guess maybe because, like I said, IPv6 has got many IP addresses in store. So yeah, however, DHCP is a good thing. The following section describes the mechanisms can be used for the case we are looking out for. Static stateless auto configuration. You guys remember, a client can create a global unique address by combining information advertised from the router, as we said, with information from its own network adapter. The router provides 64-bit of the layer 3 prefix, while the client, excuse me, while the client appends a 64-bit interface ID. The interface ID consists of the upper half, followed by the hexadecimal. This, yeah, you guys remember this. This is part of IPv6 101, I think. As a result, a client can quickly join in, the network with a unique unicast, and this is nice. IP version 6 address with little intervention. The client can also pick up other necessary information from the router, like the default address and the MTU. The router advertisements are sent periodically, or the client can request on demand. So yeah, we do know that routers usually advertise, but if the client comes up and it demands, it can, it wants an IP and it can demand from the router that please give me the prefix so that I can generate my own. The process is called stateless autoconfig or serverless. I like it. Serverless client configuration. IP version 6 addresses are determined on the fly with no dependency on DHCP servers at all, which greatly simplifies the client configuration. All the necessary address information is found on the local IP router, which is very easy to configure. That's what they said. So the example in, let's go to page. Let's say 298. Okay, there is the example in 298. This is configuring a layer 3. Remember, every time we need the switch to be configured with a layer 3, so this is just what we do on the switch. There is the appropriate IP address that is configured, and then so they say, notice that the stateless auto configuration provides only the most basic information, a client name, an IP at the IP version 6, the prefix, the default gateway. So to get some more, such as the DNS, the domain name, server address, and the other addresses, you must then try to use DHCP services. Are we together on this? Guys, please confirm. Guys, are we together on this particular point? We just said that you can it's simple to get an IP address with IP version 6. However, you would want, they said you wouldn't really need some of the things from DHCP before you get onto the network. However, it is said here, guys, hello?
Oh yeah, we're just trying to digest them.
Oh, okay, sorry. I just heard my phone go and I thought, you might find silent. I lost you guys. Maybe airtime went on mine. Yeah. So what they are just saying is that IP version 6, it's pretty much intelligent. There's little intervention you need to do before we get an IP address. However, going back to the book so that you can notice that this is very good because you can get basic information only, like the IP address, the prefix, meaning the subnet. However, you need the DNS parameters. You need some more parameters. Like if I have to go out onto the internet and do www.fnb.ac.za ACZA, TUTO, ACZA, we need DNS servers, services, domain name services. So meaning we need to know which is our domain name server so that we can be able to understand. Remember, domain name server, it resolves the words, the name to an IP address. So what they're saying is you won't get it by auto configuration, rather you must use a DHCP server to provide those additional more information. Okay. Now we went through this one. Where we here? Yeah. Okay. We just went through to this one. This is ordinary when you give it the activate layer 3. I guess you should have said no. I guess before here you already should say no switch port. Anyway, the idea, but if it's a layer 3 switch, I wonder, it's for you to find out. Some of these things are on by default. However, before you have an IP address assigned to any interface, it must be in no switch port mode. Almost like you're doing a no shut. Yeah. It's music. Oh, that's what we just got from the book now. That for you to get more information, like the DNS servers and the like, you need the DHCPs. Catalyst switches can function as a DHCP server, which is compatible with IP version 6. So they say these switches, the MPLS Catalyst switches, can act as a DHCP server for version 6 as well. The same way it was working out for version, the previous version, it can work for this one, which is compatible with version, IP version 6. In order to use IP version and DHCP version 6, client must determine whether the services are available. The router can indicate that DHCP is offered in their routing advertisement, or a client can request and ask for the service if it is available. To configure DHCP version 6, we begin with an IP version 6 pool. Remember, already we did make the layer 3, the switch port to be layer 3. So we've begun by defining the address pool similar to IP version 4. So with the global, this is the global, let me see, I didn't put it well, this one. So this is the global configuration. That's the one. It's exactly almost like the way you create a pool in IP version 4. It's just that you just need to say IP version 6. The pool, remember, sorry, you are telling the switch that I'm going to be offering the IP addresses of a special range. I'll be allocating them from this range up until from, let's say, IP address number 10 up until IP address number 250. Remember, you want to reserve some of the IP addresses at the very top. You want to exclude them so that you can have what do you call? So that you can have some reserved for your servers and those machines we don't want them to be changed. So yeah, if you intend to for the DHCP to assign IP address to client machine, specify the address prefix or for the scope with the following. There is the command which we use. So page 99, we have the one, the complete example here. It's on 89. Yeah. Okay, there we go. There is what they are talking about. Okay, there's a tip there. Guys, this is one of the reasons why I really and truly believe in the book itself directly. Oh, and I don't remember. Please remind me, there is some which I did prepare like scratch for this. Please remind me to share the book which I scratched like last week. And then, yeah. So we define a pool for version 6 users. We tell them that we want to give them this address prefix, like that one. And then we tell them that we've got the DHCP server, it's sitting there, and the DNS server. And that's the name, the address of the server. And so it is. Okay. So beside the actual DHCP server, Cisco also offers what they say it's a light version, which combines the simplest stateless configuration for address management with the DHCP option management functions of DHCP version 6. You can configure this by defining the pool. However, you should omit the address prefix command from the pool so that the clients cannot use DHCP to obtain their addresses. The client will rely on the normal stainless auto configuration using the IP prefix that you have configured on the layer 3 interface. The DHCP pool should contain any options you would like to push out to the client. After you configured IP version 6 address prefix on the layer 3 interface, you should reference the DHCP pool and also enter the following interface configuration command. This will inform the clients that options are available via the DHCP Lite server after stateless auto configuration. There's a new one. So that's what they say you must do. Network discover ND. So that so basically, to me, what they're talking, remember they're saying DHCP IP version 6 doesn't need much to configure. So it doesn't really need DHCP. However, you can configure DHCP so that it can have, you can put ordinary options like your domain name, services, and all the like. Now, when they talk about DHCP Lite, they straight tell you that you don't need this statement here. You must leave the clients to generate their own addresses using the prefix of this one, of the IP address which you put on the layer 3 interface, and then from there, the DHCP Lite will give them the additional options. Okay, and there's how it is done with example 12.6. That's the configuration of your DHCP. So now they talk about version 6. How do we do DHCP relay? Already we know what a relay is, so we're going to jump into it. That sometimes you might have a DHCP server operating on an external machine that is located somewhere else, not in this local network. It is in a remote network. So like DHCP4, you can configure the relay agent on the layer 3 interface on our switch. So you use the following command to relay the requests between the client, the IP version 6 client, and the server, which is located remotely on the other side of the city. You just say IP version 6 DHCP relay. I know the destination is this IP address. Okay. So this in itself, it says if I cannot resolve, it says in itself that I'll be sending unicasts themselves. Although by default there is no broadcast in IP version 6. There is unicast that we spoke about. So now, this one, Yabon, it goes like DHCP for IP version 4. They say you can go on and monitor the address bindings, meaning which machine has got which. So here, if you do show that one, it will say, what they say, if you say the bindings, it tells you this MAC address belongs to this IP address. That's actually the binding. It's simpler with IP version 6 with MAC addresses there. They're just pretty much very straightforward. Okay, so for you to see the pool, you do that one. So yeah, we can work on those verifying operations. The nice one important is that one. You can manually clear an IP binding with the following command. You clear IP version 6 DHCP binding like that, and then you use those as parameters. Yeah. I don't really remember too much on questions on IP version 6. Okay, is there any question? Guys? Hello? No, there's no question. Shall we move along? Okay, now what I'm going to do, guys, you're still with me, right? I didn't lose the connection.
Yes.
Yes, Mr. Vicky.
Okay, I'm going to request that I pause you guys a bit, like I promised you guys already. I would like to look out for the, remember last week I scribbled a bit of chapter 11 and 12. Huh? Yeah. So I'm going to forward what I scribbled for this one. I think I did 12 and 13. So I just want to mute and see if I can forward that to you guys before. Okay, just a second. Hi guys, I'm back. I'm sure I've been sharing the screen all along. Meaning you saw that I did send it through. Did you receive the book already? The one I sent us now. Hello? Am I off now? Guys, please talk to me. Can you still hear me?
Yes, we can still hear you.
Okay, greatest wonders. And you did already receive the book I just forwarded to you, no?
It should be in shortly.
Good. So we are through with that. That's part 2 now, I guess, isn't it? This one we are just doing and checking logging. Logging, it means it relates a bit to the AAA to me. Accounting. We are accounting to whatever it is that we did. We need to. Why is it like this now? Sorry guys, I lost the page 3. Wait. I can't remember here. It is. Oh no. Okay. So we remember I said this thing. The book is pretty practical. And once we have done and understood what is expected and understand the basic fundamentals, we should be able to roll quickly through the book, because most of this it's practical, very much so. For instance, this topic we are having, sorry, the one we have at the moment, it's like, how can you say you are aware of what's going on in a switch as it operates? So they say you can do that by using show commands to display every now and then, but we don't really have time as network administrators to record time. We can't be sitting on the switch every time and saying, hi, what's up, what's up? Okay, and anyway, we cannot really catch up with real-time events. If things happen at real time, we can't deal with that. So what do? We need a certain way, different way of dealing with it. Because, for instance, look, if a link goes down and up for every now and then, we have to be able to fix it. So the idea of logging, it's like accounting, telling or having a mechanism to account for that which happened to the router. So part of the accounting, it would be, say, let's say the network administrator, some network administrator logged on to the switch. He's not sure of his story, and now he's changed the domain name for the VLAN domain name, or the switch it's no more a what do they call them? It is no more a VTP client. It's now a VTP server. You guys know about this. The server will take over, and we don't really want a weak switch to be a server. So how can you tell? Let's say that somebody is sitting remotely and they are logging on to your switch, and then they go on and change the switch, which was the server, they changed it, now it is a client. Your network is going to go AY, which is a problem. So it is very important that we leverage the logging system available on each Catalyst switch, so that you can collect the messages sent across and be able to monitor our network. Remember, the switch activities, the switch is our intermediary device, and most the packets, they need to go via that. So it's very important that we understand what's happening on the switch. So now they talk about syslog messages. They say Catalyst switch can be configured to generate an audit trail of messages. These messages will describe what happened, okay? It will describe when did this happen and how it happened. For instance, we just went through what happened. Maybe Jerry, the rabbit came, the rat, sorry, came and ate the cable out, meaning then the switch spot will go off. Then we have to trap that. We have to know what happened. A different what will be the one I just gave an example. Somebody's sitting in King Zingi there. He's remotely accessing the head office switch. He's the administrator. Remember, we took them there last week. We said there's a new branch. He's the administrator. He's got rights, However, now he changes the client switch to be the server on VTP. Is it VTP? It is VTP, right? Yeah, those things. And then the network is now unstable. So that's the what part. That's what can happen. In this case, it's not physically the rat which came to eat out the cable. It's a human hiccup or configuration and then a problem. So these messages, the syslog messages, it also describes. Remember, we're talking about the audit trail. It describes when the problem started. It is important to know when the problem happened. And this has immediately got to do with time. You know, some of us, we've got times, we've got clocks, we've got phone. I've got my smartphone. The next thing I've got a wearable. So I've got a smart watch, but there's another watch. I've got a whatever. I'm not a watch person, but I've got one of those expensive ones. The Lux, what do they call it? Whatever it is. Which is which clock? Which time do I believe in? Which one do I take? And remember with networks, especially today, networks today, the need for speed, we cannot negotiate around it, and the need for time, because we have to hear each other. At the moment, we are sharing, there's an MC, a music box, the one which makes sure that we hear each other almost at the same time. Those things, they've got to do with time. So time, when things happen, it is very important. And lastly, we want to understand this message is how severe or important. Well, severity and importance sometimes we are used interchangeably, but they're not really meaning the same thing. We will look into that one. So when a system messages are generated, they always appear at a consistent format. And that format is shown in the figure, the next figure, this one. So it will be timestamp. We spoke about it. Then there's that one, there's the severity, there's the memo key, and then there's the actual messages description. Let's go through this. Each message, they say the messages which are generated, they appear to have the same format, consistent format, and each message contains the following fields: the timestamp, and that's what they say the timestamp does. You can go through that, and they say it contains the code. The code identify the facility code, identify that category, function or module. It tells you, which module or component on the switch is got this issue. But maybe a brighter example will tell us more. So there's what we call the severity, and it's represented by a number indicating how important or severe the event, the message. Remember, we get a message and we need to understand, is it low severity? Means the event is more critical. Is it, if it is of lower severity, a number from 0 to 7, that indicates how important or severe the event is. If the number is lower, it means the event is more critical. And that is being shown inside there, coming to here. So you see here, we've got on this, you're with me, page 309, there is this severity. 0 is emergency. So we are going to the hospital, pass to the mortuary. And then in alerts, it means then they say now the platform has got a problem. Yeah, you guys which are doing software, hard working, the engineering stuff, you'll tell me, I'm in the class, Baba. So you will tell me what a platform is. But to me, it's almost like the operating system itself. The platform, sometimes you've got virtual operating systems running on top of, like Windows running on top of Unix and things like that. Yeah, I don't know what, but they do talk about those things here. So they say at critical, which is severity number 2, they say the hardware issue, port security and STP issues. You need to know and be able to relate the emergency thing with the numbers and the like up until debugging there. You need. I guess 7 is our lucky number. So yeah. So that's the severity part. So they say now the mnemonic, they say it is just a small text telling you the category, the event within the guy here, within the here. So we've got a module or a component inside the switch which says it's a problem. So this will be a short text string telling you or categorizing that event, or to say what kind within, but we will see it better with an example, and the last one as well. In figure of that one, an event is that is triggered, and there we go. There is the example. Okay, let's go with an event in the sys facility has triggered the system message. The event is considered to be level 5. Going back to the building, there is this thing pinned? Okay, there is a level 5 severity, level 5 there. Remember, there it is, exactly there, 5. The number 5 there, it says. Remember, we said it's gonna be, the first one is timestamp. The second one, we talk about the facility, meaning inside the system. And then the third one is the severity. And then the last one is configuration. So configured from console by console. All right. Maybe they were going to explain what this thing is saying. Okay, I just wanted to clear that one. From the mnemonic conf I, you can infer, meaning you can deduct, or say that something happened with the switch configuration. So the mere fact that you can see this mnemonic called conf I, it means something happened in the configuration. Like we said, it's a problem with a man, a human being. It is not a rat, which it's not a physical thing. Meaning it's not come again, Benny. It's not a pot going shut down. So that's why the mimic in here says config. So now it's they go on to say, indeed, the text description. Remember, there it is, the text, the description. That's what it says here. configured from console by console. That's the text description there. So indeed, the text description says that the switch was configured by someone connected to the console of the switch. So this is not somebody who's far away using Telnet. This person, they say it's using console. So remember, we said we know that it is configurations. The mimic tells us a bit of what the facility in the system. However, the descriptor here tells more of a story. It says it was console by console, meaning this person is next to the switch. He's connected, he's plugged in his computer or laptop on the switch, straight on the console port, or yeah, next to that. He's not using Telnet, or what is the other secure platform you use instead of Telnet, guys? Hello, Moto. Yeah, that one. It's very secure. Yeah. So do understand? So they go on to say generally you should. Oh yeah, instead of the secured one is SSH, not Telnet. Generally, you should configure a switch to generate syslog messages that are occurring at or above a certain level of importance. Otherwise, you might collect too much information because your NID defaults to take everything up until debug, everything. So we don't want things which are obvious. We don't want too much from the switch. Rather, too little information from a switch is almost nothing. All right, yeah. All what they say is we have to set these levels of severity so that you don't overwhelm your switch collecting information while not switching your packets, your frames. You know, your switch will be busy waiting like that. So you can use the severity level to define that threshold. Figure 3.2, which is this one, shows each of the severity levels along with a general list type of messages that are generated. Think of severity as concentric circles that, okay. When you configure the severity level threshold as on a switch, the switch will only generate login messages that occur at that level or any other level that is contained within it. I think English is not my first language, but my understanding is that if I configured my severity to go up until let's say 3, let's say warning, let's say 4, then by default the switch is going to take the errors, the level 3 in, is going to take the level 2 in. It will definitely take the level 1 messages in. It will not, because I told you not to. I said it must go up until warning, which is 4. The switch will not take any notification, informal or debugging messages. It will not. Are we together? For example, if the severity is set to critical, the switch will generate critical alert and emergency. Remember, severity critical is number 2. Alert is 1 and emergency, yeah, alert is 1 and emergency is 0. There, we just said that. Log into a switch. By default, syslogs are sent to the switch console at the debugging level. So this is overwhelming because you saw, if you take things at debugging level, it means 6.5 all the way, it's gonna be taken. So we don't wanna go there. So you can change the severity like that. That's the parameter, that's the command which you use to change the severity. Login console on monitor. Okay, so this is just to make sure that you don't take too much than you can devour, than you can digest. Okay. Oh yeah, they even spoke about SSH. Remember that syslog can be seen on the console only when you are, sorry about that. Remember that syslog info can be seen on the console only when you are logged on to and connected to the console port, like the one which we spoke about. Now we set this message. This configuration were done from the console, meaning the console port. Okay. Okay. So even then, the console port is not a very efficient way to collect and view messages because it doesn't have enough space, the throughput. Anyway, I mean, there's many messages, many things happen, and it cannot hold the message. It doesn't have enough space to hold the messages. So if you are connected to a switch through a terminal or SSH session, you can redirect the console messages to your remote session by using terminal monitor, the terminal monitor command. So that, remember what we just said, we are not always going to be on the console. For example, there is a network administrator which we gave a switch and 4 PCs, and we said they must go and install it in Zingi down there in Kuruman. Now the time I need to see, I'm the, let's say, the administrator sitting in headquarters, and now, but I need to see his messages. It is not economic for me to drive from headquarters in St. Joburg and drive all the way just to connect to the console so that I can see the messages. So what they're saying is, then use this terminal monitor command to change. Remember what they said? They said by default, these messages will appear on the console only. You can only see them on the console. So if you are not on the console, meaning on the router, logged on and plugged on to the console port of the router, then you must use terminal monitor so that the messages can be able to go to your telnet, sorry, or SSH session. That way you will be able to see them. So they already said to change the severity, we use that thing. And now, wow. What is of importance? Okay, let's see. I think there's some, Okay, logging. The logging can be done in a couple of ways. I think I went past. I was supposed to come. Yeah, there we go. Console. That's the one for the console. That's the one for the console. Paste it. Okay. So they say here that system messages can be sent to the switch console. There's 3 ways. It can be sent to the console, it can be sent to the internal memory buffer, or it can be sent to a server. This server is called a syslog server. I think I jumped into this section because they only then say this, the following section covers the configuration commands that deals with the 3 ways of doing system, of collecting system messages. So they start with the first one. We dealt with that one, it's to the console. If you want to redirect, remember this one we said you must be there, you must be on site. So if you don't want to be on site, you are in head office, but you still want to monitor the one which are remote, then you use the terminal monitor. The next step, the second way of collecting the messages is by internal buffer. The switch has got a buffer that can collect. Each and every Catholic switch has an internal memory buffer where syslog messages can be collected. The internal buffer is an efficient way to collect over time. Remember, we said with the console, it's not good. It's not very efficient. There we go. We said this is not very efficient because of the low throughput. The screen is short. Every now and then it's going to go away. So this one, internal buffer, they say it is more, it's a more efficient way over time, as long as the switch is powered up. The logging is available. So by default, they say the internal logging buffer is disabled. So to enable it and begin sending messages into it, you can use the following message: logging buffered severity, where the severity will represent the either informal in the key code or the numeric severity number. If you remember from, guys, we dealt with it from here. So informational, it's either you will say informational or 6 there. Guys, are we still together? I just need to check every now and then because of the way we communicate. Before we go on to the next one, remember we are looking into the 3rd step of logging this of logging these messages. Is everybody still with us? Are we still together?
Yes. Yes.
All right, greatest. Thank you for confirming that. So we said that it's very straightforward. There's nothing to do with the buffer. They say the options which you do is to increase it. They say to enable it. It's by default it is disabled, the internal login buffer. So to enable it, you say login buffer severity. You tell it what severity you want to log. Remember, you say severity 3, then 2, 1, and 0 will be logged automatically. So with the buffer, the option to do is to increase the size in case, but I think there's a limit or something. So, yeah. So, alternatively, because you know, in time, the buffer will definitely get, it will fill up because switches are very busy. We are making them more busy now by putting the router functionality on it and putting some DHCP functionality on it and putting, so sometimes it will be complaining about the DHCP process, in which case your MOMIC, from what we learned, your MOMIC will be relating to say DHCP something, percentage or, yeah, anyway. Yeah, now that we are aware it can fill up quickly, we resort to syslog servers. So what are syslog servers? They provide the most robust method ever of logging these messages. Yeah, and they say they use UDP, which is very good. Remember I said UDP is not as noisy as TCP. And these two are at layer 4, remember. I said we use TCP. TCP is noisy because it is good, it's bittersweet, let me say. It's good sometimes to acknowledge things. Like if I send you, let's say, an email, it's good that I get an email back or some confirmation to say that I know my mail was sent. They might have not opened it and they don't know by law that the contract is signed. Immediately the mail is in your mailbox, the contract is signed. It doesn't wait for you to say, no, I haven't opened it. Whether you opened it or not, the contract is signed. Sorry, moving along. UDP, like I was saying, it's fine. It doesn't acknowledge, meaning we send with best effort. We sent and cross our fingers that hopefully it arrived at the destination. So that is why it's very, very important to use SNMP. Remember, SNMP, let's say that the messages, there's too many of them, even depending on the severity which you put it up. So we would like, imagine if it was TCP/IP, every trap or every message going forth has to be acknowledged. We will be shooting ourselves in the foot because as networkers, we don't like noise, We don't like noise, my brothers and my sisters. So they say syslog is robust. The messages are sent from a switch to the syslog server over the network using UDP. So this is nice. This is the one time. Remember, now we are not really talking about activities of a switch in terms of such as much. We are talking about logging them. It will be interesting. Where are we going with this now? Sorry. Yeah, sorry. Like I said, it is interesting now that we don't want. We are changing now to say that the switch sits here. Okay. And now it's now connecting to a server. And this is a syslog server. Remember, mostly I was saying we want to take most of the services and they must be next to the switch. This one we don't want because it's not about the clients at the back sitting here. No, rather it's about the performance of the switch. We are monitoring the switch to say, are you working well? Can you serve the guys sitting at the back well there? Are you working well? So this service, the logging of these messages, we would like it to be far away from our beloved switch, because the switch has to be working with frames, intelligent frames. So this is the time where you would definitely want the switch to be a separate box from the syslog. I wonder if I wanted to make that clear. Yeah. Moving along, we say now that syslog server over the network. So yeah, like I was drawing it now here, it's over the. Did I close? Okay. Sorry, over the network. So meaning as the packets go here, there are UDP packets over this network. So there's not too much traffic. And I just said that we would prefer that the syslog server must be remote. It must be a separate machine, and hardware, software, everything separate from the switch. So we are saying that as we send the things over here, they are using UDP. UDP port number, they said it, 514. Yeah. Okay, so that being said, you see now a syslog server can collect logs from many different devices simultaneously, and it can achieve the logging information for a very long time. To identify syslog and begin sending the messages, this is the command which you do. You say logging the host, then you tell it the server. So if we go back here, where is my friend? There. So here on the switch, sitting here, we tell them the IP address of this server here, the IP. That's the one which we put here. We tell this switch, log things at that host. Well, this is where you want to log your thing, and your threats, the severity must be a certain severity. Let's go through it. The syslog server is located at the host called IP address specified. You can enter the logging host command more than once if you have more than one syslog server to collect information. Syslog server severity level, so it can be either severity keyword, meaning informational, or the keyword, the weight itself, or the corresponding number, as according to the above, that 13.2, as according to the severity levels on that diagram on 13.2. Very interesting, very, very important. Let's go through the tips then. Notice that each of the logging messages destinations can have a unique severity level configured. For example, you might collect information messages of severity debugging into an internal buffer while collecting severity level notification to a syslog. Yeah, I'm sure you understand that. It's English. It's right like Brenda Fassie in the Peppermint. And then the next tip, let's go through. By default, a switch will generate sys messages every time it detects an interface down or up. This could be good, yeah, and until, this sounds like a good thing, until you realize that the Syslog server will be receiving news for every user powering their PCs. So every time somebody power, then the switch port will go up, and then it will tell the Syslog that, hi, somebody is up. Yeah, and every day and all the time. So each link state change will generate at least, would generate at the come on level 3. If it is a link state change, and remember already this PC link state change is when the port goes on or the port goes off. So we will have two messages, two kind of severities, severity 3 and severity 5. Let's go through it. Each link state change will generate a message at the errors level 3 severity level. In addition, so to this line protocol state change, it will be at the notification level 5. To prevent this from happening with access layer interfaces where end users connect, you can use the following to configure. So each and every place where you've got users connecting, you know that they're going to come at night. When they go home, they switch off the PC. When they come back, they switch it on, switch off, on. So the best, because we told the switch, we cannot afford to tell the switch not to listen to link state changes. However, we can go to specific ports and take note, please, people. With configurations, the IF means we are in interface mode. We are not in global configuration mode. We are in interface mode. So you need to do this command of saying no logging event link status on each port which end users use. Because they're going to switch off the machine, they're going to switch it off. And the root and the switch will definitely report that there is link thing. There is link state changes. There is up and downs. So take note. Okay, before we've dealt with the 3 ways of logging, we said we can log to the console, we can log to the buffer, we can log to the syslog. Before now we remember that we spoke about time. One of the things which 312. One of the things which came first, very important, is timestamp. Our messages have to have a timestamp. And it is very adamant. I don't know how to explain how important time is in our lifetime in networks. So what about time? Remember I said I can have 3 time sources. My phone has got its own time. My laptop, I'm sitting here, it's got its own time. My desktop, it's got its own time. My watch, all of them, they've got different times. But then we need a bit of synchronization so that we can agree, and sometimes agree just to disagree, if you know what I mean. Yes. Any questions before we get to the down to the bottom of the matter now. Any questions? No. Yes, maybe. Okay. So adding timestamps to a syslog message. If you need to review messages that have been collected and achieved in the internal logging buffer or on a syslog server, message timestamps become really, really important because it's obvious we're dealing with real-time stuff. Okay. So by default, Catalyst Switch add a simple uptime timestamp. Look at it, uptime timestamp to the login message. Suppose that you find an important event in the logs, and now you want to know exactly when it happens. Remember, by default, the switches, that's what they said, they will default to say uptime timestamp. Uptime timestamp meaning the router came up at 1. From 1, it start calculating uptime. How long is it up? And it calculates. For example, here at the bottom here, they say the router is up for 20 weeks, 2 days. Huh. What the hell is that? If I'm a network administrator, I have to first sit with my calculator and remember day calculating and week calculating is not the same as the calculators we use. Now I must become an engineer in computing days instead of doing my actual work. This is not good. So uptime timestamps, they are not very good. You know, even worse, they say at time as time goes on, the uptime stamp becomes more coarse and difficult. That's what we are now referring to. So that how can we work that one? To add the correct times, go to page. That's the one, next 17. Which one is that one? We are not going to go that one first. But you see, now they are already, this comment here, hemmed. To add the correct time, go to page 317. It means as we go on and we work, there will be a problem because whatever we'll be doing from this page, from page 1312, 13 something up until 1317, we'll be working around time which is not correct, because that's what they said. If we want to do the right thing, go to 313. But let's see what they really are talking about. Sometimes you also will need to correlate events in the logging with several events. In each case, it is important to synchronize the time. And this is what I've already spoke about, that sometimes you've got your phone, your laptop, your desktop, all of them, they're using different phones. They need to be synchronized, and they need to be the same. So yeah. Now the next session talks about how to setting the internal clock for it to be right. To me, there's nothing to it, because they say you can check what it is before, you just say show. And if you want to clock it, you say the clock is this time. However, there is sub-configurations or configuration options. Some of them options are talking about what we know, Like South Africa is not sharing, the world is not sharing the same time zones. Some are -1, some are all the like, but they show those things to you very, very well, how to set them up. However, they said we must go to page something. Termed by this, define summertime for every year. You see, some of the people, they don't even use, they've got summertime. So putting it and making it, you need to own the whole concept and know where you are. In South Africa, we are, I think GTM -2 or something, but they do those things. Yeah, and yeah. So we don't deal with summertime, so I'm going to jump the summertime. But you need to know, remember, networks are international. We are no more talking about jurisdiction of, yeah, we are in South Africa, we are not in, we are all over. Cyber doesn't have any jurisdiction. A concept which is very interesting. That's why, yeah, the industry of cyber law should be an interesting one. Moving along. Okay. We're not going to go through those things of times because, yeah. So now, using NTP to synchronize with an external time source. So in here, we were trying by all means to set our own time on ourselves to say it's gonna be correct, but we are not even sure whether we are setting our time correct, because I'm sitting on the switch now, and now the time I wonder, which time should I use? The one on my phone, the one on my whatever. Even the time I'm setting on my phone, on my with this clock thing, even the one which I'm setting, I'm not sure if it is the right one. However, networks need accuracy. So what would we want to do? We would want to have an external server or an external source, time source, an external device which can provide us with time, and then make it a point that we are in line with that one. So how is that one done? It is done by forming what they call stratums, like that. The stratum 1, 2, 3, and so the ones at the bottom, I'm on figure 13/3. Okay. So the end devices will depend, let's say, on stratum 1, which is switch A, and or also called NTP server. You see, in this case, the switch itself, it can be an NTP server. However, it needs to relate to upper NTP servers, one of which must be either GPS or autonomic clock. So at the very top, the one which we trust, they've got authority, is stratum 1, and as we go down, we can only trust under. So how is this done? Okay. Let's try to work on this one, and then we know we are done. Can pause. To synchronize the clocks across multiple switches in a network from common trust time sources, you should use the NTP protocol. Each switch still maintains its own internal clock, but each periodically synchronizes its clock with one or more external time sources. The goal is to synchronize to a source with this with some level of implied trust, meaning that the time is accurate from that trusted source. NTP, the network time protocol, can also cope with the delay that occurs from the time source transmitted, whatever it is that they are talking about there. Okay, so with NTP, time sources or servers are arranged in a hierarchical fashion, with each layer of time server synchronizing with other servers in a higher layer. Ideally, a networked device should synchronize its time clock with an authoritative source, meaning the one which we trust, a trusted authoritative source, or one that offers the most accuracy. Authoritative time sources can use towards one authoritative source. Okay, so they spoke about the layers. Each layer of the hierarchy is known to be a stratum, and this is the picture which we referred to earlier, where the stratum number indicates the number of NT hops needed to reach to the top, and at the top is trust mode. Authoritative time servers are located in stratum 1. NTP servers that synchronize with stratum 1 are designated as stratum 2, and the NTP stratum keeps incrementing towards, as we could see on the Lokozana. As we could see on the diagram, the number here increase as we go down, but the trust increase as we go towards the lower number here at the top. So the NTP stratum numbers are also serve as indicators of time accuracy. There is table thing here, table 13.2. It lists the possible modes that we can have. We can have server mode, PM mode, client mode, and broadcast. And there they describe that the server mode, it synchronizes with the sources in a lower stratum and provides time sync with the servers, clients on the higher stratum. Client's devices synchronizes its clock with the NTP server. It doesn't do anything else. It's straightforward. While a peer device, the device exchanges time information with other peers. That's what they do. Then they talk about the broadcast or multicast. Yeah, please take note of these modes. This is a very nice question to relate for and to your exams. Now they just go on to say they configure NTP, and to configure NTP there, it is very straightforward. You say NTP is this one, and then you say preferred if you want it to be the preferred one. You see they say list this, the first one that you are listing, this is my NTP server 168, and there's another NTP server. So like you said, in that case, you can repeat the NTP server command to specify more than one time source. In that case, you can add prefer keyword to identify which server to be preferred over the others. By default, NTP version 6 is used, and NTP version 4 adds IP capabilities. So you can see here on the you can see that there is either NTP version 3, you can either choose 3 or 4. So they say and for version 4, that's when you want to have layer 6, IP layer 6 level version 6 capabilities. Okay, and from there they just talk about show commands. And yeah, I guess, can we call it a day? I'd like you guys to finish this one. There's 2 pages. Unless, yeah. Using the SNTP, it's simple. The S it's for simple. Okay. Oh yeah. They say when you secure NTP, it's like, remember, we want to trust somebody. However, you need to trust somebody you know. So for you to secure that, you use those configurations here. You guys from security, you'll know about the MD5s and those things. What is of importance to me? It's these guys. Okay. When you do the access group, so they say for the NTP access group command, remember the access group command in here, it's when you have an access list. You want to say access list, you want certain people, you're firewalling, certain people must do in, certain people must out. So if you want to group, to bind it, meaning on a NTP server, you must say access group, NTP access group. Then you can either say server only, server, peer, or query, that one. So they say for the NTP access group command, you should use one of the following keywords to specify which type of NTP activities should be permitted. Serve only, meaning only synchronized requests are permitted. Nothing else is permitted except synchronize. If you want to synchronize, come. Otherwise, nothing else. So the different one, if you put it as serve, synchronization and control requests are permitted. So this one is more favorable than serve only, because it's it allows that one, control requests as well. The device is not permitted to synchronize its own time clock. Yeah, that's what they say. So if as a peer, synchronization control information are permitted, device can synchronize its own. These ones are the ones which are important, and as such, I said you could expect some from the for questions. They said we must jump to 317. So you see, they were just protecting things. 317 is where they said you will have the answer. Adding timestamps on the login messages. Could I suggest that you guys go on and finish this up? Bring up questions if you've got any problems when we meet the next time. Can I have any questions now before I am going to say, before we close the lesson for the day? Do we have any questions? Do we have any comments? Just to verify stuff, I wanted you before verifying. We said we needed two class reps. Did we have anybody nominate, or do we have answers to those? Glenn tells me there was a bit of, at least here and there. Do we have our class reps sorted ready?
For now, I've been sadly nominated to be the class rep.
Can we have
So
a
Glenn will be our
female
class
ladies? You are not represented. Can we kill you now? Please, we need somebody to volunteer to be a class rep. Otherwise, you know, anybody? Okay. Hopefully me and Len can be able to understand your needs. And I wonder whether we will accommodate you guys. But you see, guys, sometimes silence means concern. I'm telling you, you are not represented well. So we can go on like this, but think about it. And
Okay, just to interject, the email is not yet in. Maybe you double check your, you just sent an email today for chapter 13. Yeah, just double check your outbox. And then once more, today's class was much better than last week. We noticed the slides that you've made that we're following. If you could also share those slides with us, it will go a very long way towards helping us study the textbook, okay?
Really, guys? No. Do you want the slide?
Absolutely.
Or the book as well?
Yes,
please. I mean, remember, you guys are cheating me sometimes. You need to come prepared. And if there's no action, there's just nothing. There's no spoon feeding. And if you go through the book is practical. You will be able to ask questions and moving along. Anyway, you see, you are requesting for the book marked. Yeah. You are requesting for slides. You are requesting for recordings.
Yes, please.
Yeah. So I need you guys to read. You guys must give me a book similar to what I'm sending. You see, I sent you 4 chapters already. So can I request maybe we start grouping each other? Then people will be dedicated. I know these ones are going to deal with chapter 15. This will deal with 16, 17. The core of the story is being told. Can you see now we are just putting the skeleton, we are shaping, we are putting the pieces, the flesh up on the skeleton. Unless if we are still lost. Are you guys with me?
Yes, we are with you.
So I really need you guys to prepare so that today, today was very, very interesting. We got people talking. I was talking, but and we never got cut. So it means, and it shows interest. And I'm not sure if guys, you can grasp remember, the basic key thing which I come to class for is to tell you why we are doing what we are doing. And I explained why we want our switch to be a router, because we don't want broadcast to go past our switch. And we want services to be nearer, in the nearest proximity. Why we're doing DHCP? because you don't want to wake up in the morning because somebody is switching on their phone and now the phone mobile thing wants IP. Oh, so because somebody wants an IP, So that's the reason I'm trying to put the why, so that then it's pretty much kind of easy. Disciplinary code. Sorry. So that then it can be simpler for us to understand. Where is the mail? Did I send the mail? Oh, I'm not sure. I think there could be something wrong with TUT email, or is it me? Because it says I'm disconnected here. Let me see. 11 to 12. But it doesn't reply at all. Didn't I do this? By the way, what did I want to send? Part 2. Is it? Yes, no, it was a PDF. No? It was not a PDF. Sorry. PDF. Yes. I tried again. I'm not sure if it is me and TUT and my email, but it's saying it's trying to send now. And I'm trying to, it's saying it sent. It sends 2 of them. Already it sent the first one that long time. No, it's two copies. Only now it went through. I'm not sure what could have been the issue. You want to confirm, verify before? Hello, Radlan? Hello.
Yeah, once it's in, I will confirm. And then lastly,
Okay.
I think
in the
went
meantime,
beyond.
Is it fine if I stop the recordings?
Yes, please.
Yes, you can stop there.
And excuse those who have class at 11:30. It's already 12 o'clock now. So in future, let's try to keep it within the 11:30.